Hi, my name is Sarah Coffin, and today I'll be talking about the Rutherford and Bohr models of the atom. To start, we need to start a step back from both of them, and that is J.J. Thomson. Now, J.J. Thomson proposed the plum pudding model in 1904. And in this plum pudding model, he had the idea that there was just these negatively charged electrons that he had found a couple years prior, and they were just floating around in this just cloud of positive charge. And so that's where you call it the plum pudding, because this bowl of soup essentially, or this bowl of pudding that is positive charge, has just these placed negatively charged ions or electrons just in there. And we don't eat plum pudding a lot anymore, but that's essentially what plum pudding was this bready pudding with plums or raisins in it. And he proposed this because with the knowledge he had, it was a good idea. In 1911, Rutherford came out, and using the information that J.J. Thomson had put into place, Ernest Rutherford said, I think it's a little bit off. And so what he came up with was this idea that there is this positively charged central area, which we now call the nucleus. And so we still thought there's just this cloud essentially of negative electrons, but he thought it wasn't just a soup of positive. He thought it was kind of centralized. And so he proposed this in 1911, and in 1911, he came up with an experiment that most of us know. It's called the gold foil experiment. And the setup was pretty simple, but when you think about the fact that it's 1911, pretty complex. But there was this detection screen placed around, and it had a slit in it. And then over here, they had the alpha particle emitter, and they used a high energy alpha particle. And then they had this gold foil in the center, which would get hit by the alpha particles coming through the slit. And they're going to shoot the alpha particles through and see where they went. If J.J. Thomson was correct, this is the result they expected. They expected to see the alpha particles go straight through the gold foil. And this is a close-up of what would be happening, because if it's just a cloud, those alpha particles are just going to move straight through it, right? They're not going to be repelled anywhere. They're not going to clash with anything. They're just going to move through. So they expected to see only one spot on the screen that was hit by the alpha particles. Instead, what they got surprised Rutherford. They got alpha particles all over the screen. They found some of them were going straight through, like they expected, but there were also some that were just slightly angled off, as if they hit something and kind of it skewed its path. Some were coming all the way straight back at the alpha particle emitter. And so from there, Rutherford was like, okay, that means there's got to be, a central spot right there, that right in the center, that has to be lots of positive charge. And so he's like, okay, I think there's a small area that's super positive, and then the electrons are around it, and they're being kept there because of that strong positive charge. And he did some math with it, with the size of the alpha particles, and I want to say it was 1 divided by 3,000th, 1 divided by 3,000, that percentage of the alpha particle, it was tiny. And so he's like, this is a tiny, tiny, tiny spot that has all of the mass and all of the positive charge. So he finished up there, not actually. Bohr comes after, and Bohr spent some time in 1912 in Rutherford's lab because he was very intrigued by this whole idea of the atom and the atomic model. Bohr, though, he found some problems. Whenever he thought about that positive charge in the center with the negative electrons around, he realized that the electrons, as they lost energy, because, it's going to lose energy as it's moving all around, he said, as it loses energy, it's going to slowly spiral and collapse into the nucleus, and then the atoms will explode. He said, and that doesn't make sense because everything would always be falling apart, and we're not getting that. So, we did not get kaboom. He proposed the Bohr model in 1913. And he said, there's got to be an order to this chaos, right? And he still was like, okay, we still have that positively charged nucleus in the center, but he called these areas around it stationary orbits. And he said that the electrons have got to stay in these stationary orbits. Oh, and there must be some laws around when they can pass from orbit to orbit, but they've got to stay in them. And so he found, one of the ways he found this was that the electrons, whenever they moved orbits, they only emitted light. They didn't emit radioactive energy or anything like that. They just, there's flashes of light every time they did. And so he said there's got to be an order to it, which after Bohr didn't come up with the order. He did pretty well, right? He made a lot of progress. But from that, we now have what we learn about in basic chemistry classes and physics and such. We have what's called the S and P orbitals. And we learn about all these things that don't have a lot of impact on your life unless you're going to be a chemist or physicist. But we did find them. And every student that is going into science now learns them. And so in the time span from 1904 to 1913, that's only 9 years, they found 3 different models of the atom down to almost what we look at today. Bohr wasn't quite right, but he was pretty dang close. And for research, that's crazy fast. So those are the models of the atom.